something the other day on some teaching techniques, and one of them was, one of the things you can do is have an expert in the classroom every day, right? So, like, I might come in today, and Amber, you'll be my expert. So anytime I have a question, I'm going to ask you today. And then the next time it's going to be Harvey, and so then every time we come in, I'm like, I don't know, that sounds like a lot of pressure, doesn't it?
Yeah. And I call the other experts. One of the teachers is Inventories.
Oh, is that right?
Miss Johnson.
Lee? I like Lee. She's fun.
She's a good teacher.
She thinks good on her feet.
Yeah.
Well, she thinks well on her feet.
She used to be a lawyer or went to law school, and you can tell when she's talking, and she's really animated, and you can tell that's what she did.
She has some practice with it.
I have to live and argue with her.
Well, she and I have worked some on the online teaching in terms of she has an interest in it, as do I, but we also have an interest in making sure that there's that there's credibility to it, that we make sure that as we're going to offer our programs that we have, we make sure that, like in my 343 class.
Integrity, whatever that was.
Yeah, you're required to use the respondents because it isn't the same test if I let you take it online and you have open book, open note, and there's no way, if we don't use the respondents, there's no way to know that. And there's still some question, but it's not like it's a
free for all.
Right, open access kind of thing. All right, enough probably about that. Chapter 6 is about inventory and supply chain management, inventory analysis and economies of scale. What we talked about with EOQ was is the economic order quantity back in 343. And basically, this is just a quick review of that. The challenge is, of course, that they use different variable letters. If you remember, we use the square root of T2 times annual demand times C sub O over unit cost times C sub I was our approach. Well, they actually use more terminology of what we're familiar with in this text. But key financial indicators of supply chain performance are things like return on asset and net present value. The problem with that is that those are lagging indicators. So what we have to figure out is, in order to achieve a good return on asset and a good net present value, what does the supply chain have to do? Okay, accurately matching demand with supply is the key challenge. If you talk about inventories, 2008 logistics costs, so these are dated because I haven't got an updated version of the textbook just because I think that's expensive and not changed it that much. Freight transportation in 2008 was $864 billion. Okay, inventory expense was $420 billion. Administrative expense was $60 billion. Logistics-related activities were 9.4% of GDP. Okay, so if we think, oftentimes I see that as one of the, not as much anymore, but it used to be one of the overlooked areas of opportunity. We focus so much on trying to improve maybe the manufacturing cost of something, and we wouldn't think about how can we better get it to and from location, and how do we better match our production to our demand. So inventories arise for a variety of reasons. I'm not a believer that inventory is evil. I'm a believer that inventory is a tool, that you need to consciously decide how you're going to use it. Okay. And so there is a cost of overstocking, right? If I have too much inventory, I have to liquidate, I have obsolescence, right? One of the most painful lessons I ever had, we were phasing out a product model at one of the plants. I may have told you this story before, but I had worked extraordinarily hard as a supply chain manager at that plant to make sure that we got our inventory levels down to almost nothing. And so where we expedited a couple of pieces of glass in and paid a higher premium for that so that we didn't have a bunch of glass left over. But then in window manufacturing, glass is one of the key things, right? It's one of the key costs, right? So we get done with this, and I'm in my Story City, Iowa plant mode. I've managed my inventories almost down to nothing. I'm so proud of our team for how well we've done. And we get the bill from Cardinal Glass for the glass that they're going to obsolete, and it's like $250,000. And I'm saying, and I won't repeat what I said, but I was saying, how does this happen? Well, how it happens is that I'm supply chain manager at the plant level, and we have a supply chain manager at the corporate level, okay? The supply chain manager at the corporate level had agreed with the Cardinal plant that it's more cost efficient for them to produce glass in large batches. So they could produce in large batches, but they would only ship to us in smaller batches. So while I'm thinking I'm only ordering this much and that's all the inventory that I have to worry about, there's a whole other batch of it out there at the Cardinal plant that I don't know. And when we did one of those expedites, it triggered them to do a whole other large batch of the glass because we didn't know that we needed to communicate to them to stop, right? And so, again, we get this bill for $250,000. And I about come apart. And the corporate person, and it's all perspective, right? He's dealing with them on a lot of things. He's okay with it, right? I am not okay with it. We had worked so hard, but it's that obsolescence cost. I mean, you can get hit with stuff like that in your supply chain, and you have to decide, as the owner of that, it really was our responsibility to cover the cost for that. That was our agreement with Cardinal Glass, right? But when you're going through an obsolescence, you have to think down that pipeline to make sure that those things get communicated.
When that happened, did you get the color for it, or was that a big deal to be charged $30,000 unexpectedly?
It was definitely for our plant a big deal, but my plant manager, I had the most awesome plant manager there, and he was like, when I explained what happened, he was like, I understand how it happened. We're just going to know, going forward. Because he knew how closely we were trying to manage it, and that's just a piece of information that I didn't have.
Yeah.
And what happens is those corporate supply folks are out visiting suppliers and vendors and doing all their thing, and so they're not involved in the plant meetings about obsolescence, right? And so we just missed that. So, again, whenever I talk about documenting, those kinds of things, the next time we went through an obsolescence, that was one of the steps in the process. Make sure that, you're talking to the corporate folks about how does that impact our key suppliers there. I'll give you another example just because I think it's a good practical example. And Joey, I know you've got to go here pretty shortly, don't you? So, but here's the example of why I think he's such a good plant manager. We had worked on a project for months we were revising the scheduling system. And we had tested it forwards, backwards, upside down. Harley, you'll appreciate this one. We got to the end and we had one thing that needed to be adjusted. And so the programmer went in and adjusted the one thing and didn't test it after he made that adjustment. And he put the comment in the wrong spot and it crashed the program. So when we went to go do schedules that night, everything was a complete disaster. And instead of bringing all of us into the room, because we had been working hours upon hours on it, it was one really, really bad day of production because their schedules were completely out of whack. And that's expensive. You're talking about hundreds of people not being productive. And he brought all of the staff in and he's like, I know that we're going to fix it, and all I've got to say is I know that you worked really, really hard on it, and it's unfortunate that didn't pay off in that first day. That was the end of the discussion, And it's the truth. We had all worked incredibly hard on it, and it just, I've had other managers that would just blow a gasket and go, you should have. Okay. Yeah. So those are a couple of my worst case scenarios at Pella. Those were memorable moments for sure. But again, that's what made him one of the best plant managers I'd ever worked for, because he was very practical and very fair, He expected a lot out of us, but he was very fair. All right, but on the other hand, if we're not overstocking and we understock, then we can lose sales. And depending on the product, you might not ever get them back. If you are stocking shampoo in Walmart and I'm in Walmart to buy shampoo and mine isn't stocked, I'm probably not waiting until they stock it. I'm buying something else, right? And so there's that opportunity to lose sales, resulting in lost margins. And so when we think about how inventory builds up and what's its purpose, right, it's in our buffers, right? A lot of times we have inventory in our buffers just waiting for some activity to take place. And so just real quick, you're probably going to want to finish watching the rest of this, and then I didn't check to see if you had your exam done or not, okay? and then there'll be homework for Chapter 8, and I'll try to put some problems out there for Chapter 6 as well. Okay. And I think it's interesting to look at different industries and the actual time it takes to get something done and the actual activity time. And that should relate to some of your projects. Because a lot of you are at that point where you're talking about flow time and efficiency in your projects. So let's, a couple of the things that I've noticed is on the couple that have reached that point that I talked about, your flow time, we've got kind of the time that it takes to do each activity, right? And then we're identifying what's value added and what's not value added. Okay? And so your theoretical flow time is just going to be those value added activities, right? And you're going to take your flow time efficiency by just taking those value added activities divided by the average time that it takes to get through the process, the entire flow time of the process, right? And so if you think about from the life insurance industry, a new policy application oftentimes takes 72 hours from the time that a application enters the process until it exits the process. The value-added activities in that are actually 7 minutes worth of time. So the flow time efficiency is less than 1%, right? Like 1/6%. Okay? Consumer packaging for new graphic design. The time that request enters the process until it exits the process is 18 days. Okay? The actual time that is value added is 2 hours. So you're talking about 0.14%. And you can see that, how things come in and we put them someplace and wait until we have time to get to them, right? That's what we're talking about here. With this commercial bank for consumer loans, the average flow time is 24 hours. The actual time that somebody spends doing value-added activity to that is 34 minutes, making that 2.36% efficient. Okay? Hospital patient billing, if you have ever had that, it's horrible. Okay? On average, it takes them 10 days from the time that the billing, it enters the billing process until it exits, but it really is only 3 hours worth of work in that entire time, so it's 3.7% efficient. In automobile manufacturing for financial closing, it can take 11 days from the time it enters until the time it exits. Okay? And the theoretical flow time is 5 hours, so it's 5.6% efficient. So, all right. So again, places where you can look for, in your process, one of the things that I would expect you to look for is those things that are not in the value-added realm, that are necessary but not value-added, or just plain not value-added. What of those can be eliminated or changed to make your process go faster? Okay? And then this is just getting back into our operational flows where inventory is equal to throughput times flow time, right? Nothing wildly exciting about that. But when we get back to why do we have buffers, if you look on the right side of the screen where those little green arrows are, those are the different reasons why we have buffers, right? No, I don't want to download anything right now. Thank you. There is the cycle or batch. So sometimes it's more cost-effective if I do things in a quantity. For example, if I have an oven, okay, and I have parts that are painted that need to be dried, it's more efficient for me to do a batch of parts at one time to fire the oven up to do that batch than it is to do one part at a time. So that's why I might batch things. Or when I purchase something, maybe I'm going to get a quantity discount. Okay, so that's why I might batch in that situation. Okay. I might have buffers because I need safety stock. If my demand isn't consistent, right, and I have variability in it, then I'll want some safety stock to cover for that. We can have seasonal safety stock, and that you can think about. I would say Pella's seasonal safety stock. Pella's seasonal stock is a little bit different than maybe what you think. You can think of it like maybe for Christmas, like you might stock up for things to have them available for Christmas. On the other hand, like Pella's is people primarily do their building in May, June, July, August, September, October, right? That's the busier times of the year for the building industry. So come November, we can either not have as many people producing, or we try to balance that out and have about the same number of people producing, ramp it up a little bit in May, but build inventory November, December, January, February, March, and April, so that when the busy season starts, we're able to pull from that inventory and we're able to keep the same workforce, okay? Because there's advantages to having that same quality workforce, okay? So that's a reason that you work with inventory. So again, I don't know that it's not evil. It is a choice. It's a tool and how you decide to use it, okay? And then you can think of it from strategic. They talk about flooding. I'm assuming they're meaning like you flood the market and try to make issues for your competition, okay? When we talk about the cost of inventory or holding costs, you can have the physical holding cost of your out-of-pocket, the financial holding cost, meaning I've spent it on this, so therefore I can't spend it on something else. That's the opportunity cost. And then the low responsiveness to demand or market changes and to supply and quality changes, okay? Because one of the things we find at Pella is incredibly, I say it like I still work there, it's incredibly painful to find out that you've been building inventory for 3 months and that there's a quality issue, and you have to go pull units from inventory, unwrap them, and fix them, and rewrap them, and put them in, right? And so if you don't have tons of inventory, then you don't have to go through that process. But when you build up inventory, that's always a risk, okay? And that's another reason why doing the quality checks as you go is so critical, because you don't want that to happen, right? You don't want hundreds of units in inventory that are a problem. Okay, so we've talked about holding cost variables before. So capital H in this book is holding cost variables. And we're going to do H plus R times C, okay, which again, different than what we talked about. Our holding cost before, we would do unit cost times C sub I, okay? In this case, H is a fraction designed for insurance, security, warehouse rental, lighting, heating, and cooling, and C is that variable cost of the unit, and R is referring to the rate of return to account for opportunity cost. So think of R as like your interest rate. So truly, when interest rates are low, your holding costs are less, and so it isn't as large of an issue to hold inventory. However, you still have the insurance, security, warehouse rental, and all of those things that have to go along with it. So in this case, their variable C is what we used to have for U, and then our C sub I is what they have for H plus R, if you remember that from 343. So holding cost variables. Our annual ordering cost, we had C sub O was our cost to order each time. They're calling it capital F, okay? Q is going to be the amount that we're going to order, and R, capital R, is going to be our annual demand. And they're doing that because capital R can represent throughput per year, right? So we're trying to be consistent with the variables we're using in this textbook, okay? So we've got this example. How many of you ever heard of this company, Howard's Gear? Okay? Retail Inventory Management and Economies of Howard's Gear. So they have an annual jacket revenue of roughly $1 million. The jacket sell on average for $325, okay? And Palo jackets sell for $325, which represent a markup of 30% above what Palo Gear paid its manufacturer. Being a profit center, each store made its own inventory decisions and was supplied directly from the manufacturer by truck. A shipment up to a full truckload, which is about 1,500 jackets, was charged a flat fee of $2,200. To exploit economies of scale, stores typically ordered full truckloads, and Palo's cost of capital is approximately 20%. Okay. Well, as I read through that, I typically try to pick out variables as we go, right? So if I have roughly $1 million in inventory, or excuse me, $1 million in retail sale, and each one is $325, I can get my annual throughput by taking $1 million and dividing it by 325. Okay. Being a profit center, each store makes its own inventory decisions. A shipment up to a full truckload, which is about 1,500 jackets. Okay. So, that being said, let's go ahead and keep moving forward a little bit here. In terms of their inventory buildup, and you remember we talked about in the perfect world we have the sawtooth diagram where we go from zero inventory up to Q, which is the amount that we're ordering, and it comes back down to zero right at the moment that we run out or next truckload comes in. and it goes right back up to Q.
So that's just in time inventory, kind of?
Yeah, that would be what that would represent. And that's that perfect roll scenario, right? We're not seeing any variability in the demand, and we're not seeing any variability in the time that it actually arrives. So we're saying that our trucking company is perfect, and we're saying that we know our demand perfectly, right? And so the other thing that we know is that half of our Q is our average inventory, right? This is our model. Q divided by 2 is our average inventory, okay? Our number of orders per year are going to be our total demand divided by how many I order each time. And that one, I always go back to the very simple example that you would get every time. If I said my annual demand is 12,000 and I ordered 1,000 units each time, how many times a year do I order? Yep, so then we take 12,000, my annual demand, and divide it by the amount that I order each time. Okay, so go back to a simple example if you need to get there. Okay, so the average number of windbreakers in inventory is our Q divided by 2. Okay. So if we're going to evaluate our current policy of ordering 1,500 units each time, our average inventory, Q divided by 2, 1,500 divided by 2 times 750. Okay. We were given in the problem that we had a sales price of $325 and a markup on that of 30%. So that's going to mean that I need to take my unit cost times 130% to get to 325. So again, this is that sometimes, in the past, we would just tell you, C is this, right? Now you have to think about what those relationships are. And so our average cost then is 325 divided by 1.3 or $250. And going back to our annual cost to hold 1 unit, capital H is small h plus R times C, okay? Small h is our holding cost, and R is our opportunity cost, so we've got 20% there times 250. So if I hold 1 unit per year, that's going to cost me $50. And so if I'm going to hold my average inventory, 750 units times 50, that means that costs me roughly $37,500 a year. How often do we order? That's that, again, that annual demand. 1 million divided by 325 says that my annual demand is 3,077 units. Number of orders per year, annual demand is 3,077 divided by my 1,500, which we're given. So then I'm going to order 2.05 times per year. We know from the problem every time I order it costs me $2,200. So 2.05 times 2,200 is 4,510. So our total cost is our holding cost plus our ordering cost. So 42,010. So relatively, and again, that's just right back to what we did in 343, just with substituting some different variable letters in there. But it's the very same concept that we looked at. And so we can find our most economical order quantity if we, wanted to work through a spreadsheet, which we don't, right? We'd rather use our formula EOQ, which I spend a lot of time. You can see here, you've got your holding cost right in the pink, you've got your setup cost in the blue, and the total cost here, and where they cross is our economic order quantity. So if I look, our economic order quantity should be somewhere above 500. So 2638, 2623, 2618, and then at 530 I start to go back up. So I can visually see, as they charted it, that it's going to be about 520. But I can calculate it, again, by taking the square root of 2 times our cost of ordering times our annual demand divided by that holding cost. Okay, so if I'm going to do that, 3,077 units per year is 59 units per week. Unit annual holding cost, 20% per year times 250 gives us $50 per year. The 250 is that unit cost of each coast. So our optimal order quantity is going to be the square root of 2 times our annual demand times our ordering cost divided by our annual holding cost. So 520. Okay, so we come pretty darn close to what we saw when we looked back here. Right? We came right to that with 520. Okay? Now we start to look at this and think about what information do we know and how can we answer different questions with it. Okay, so number of orders per year. If I told you that we had annual demand and mean, we just divide that by the quantity, the 12,000 by 1,000. Well, in this case, we know that our annual demand is 3,077, and we're going to order 520 each time. That means we're going to order 5.9 times per year. Our time between orders is just the inverse of that, Q divided by R. And, pardon me. And my annual ordering costs are going to be how much does it cost me each time I order, times how many times a year I'm going to order. So R divided by Q, which is 5.9, times our S, that's $2,200 each time we order, tells us that our annual ordering costs are $13,008. We know our average inventory is Q divided by 2. If EO2 is 520 divided by 2, that means that our average inventory is 260. My annual holding costs are going to be my average inventory times that cost to hold a unit. So 260 times 50 is going to give me 13,008. If you remember, that's one of the keys that we talked about in 343, is if we do EOQ right, our annual ordering costs and our annual holding costs are actually equal to each other at EOQ. Okay? Now I can get to my average flow time, which is my inventory divided by my throughput. So in this case, my inventory is going to be 260, and my total throughput is going to be, must be 3,077, right? And so I can get my average flow time. So there's a tweak we didn't have in 343. We didn't look at average flow time in 343. So things that are associated with our different batches in terms of order costs, we talk about if we're in production, if I have to change from one production to there are machines that have to be set up differently. There's costs to change over that process. There's transportation costs, and there's receiving costs. So all of those would be included in order costs. Holding costs are the physical cost of holding the unit, the cost of capital, and the cost of obsolescence. Okay. Okay, so basically then, if you're interested in the total cost, this is a shortcut formula for that, right? We're just basically doing some revisions to this formula to get here. And then this is just talking about budgeting for growth. So last year our sales was $100 million in inventories. It was $100 million and our inventories were $20 million. Next year, if we have $200 million in sales, what's our inventories going to be, and days of inventory. I'm trying to think. I apologize. I didn't look at this slide before class. I'm trying to think what we're trying to get across with it. I may come back to that next time for a quick minute. That one seems out of pocket to me. So, all right, we're going to move on. I'm not going to spend a lot of time trying to figure it out. We'll figure it out. I'll figure it out outside of class and then come back to it. So our learning objectives for this, if we increase our batch size, it increases our average inventory, as we know. And if we increase our average inventories, what happens to our flow time? It increases. The optimal batch size is we're trading off that setup costs and our holding costs, and we're trying to find that where they are equal to each other. To reduce batch size, you have to reduce your setup time. Okay, one of the, I don't know why it's not intuitive to people in the manufacturing plant in many cases, but if you're able to change that setup time, so that's why we focused a lot on setup time reductions when we were doing major events. If we had a particular process that would take a long time to do, we'd come up with ways that we could decrease that time, and that's going to take time and inventory out of the system. Okay? If demand increases by a factor of 4, it's optimal to increase batch size by a factor of 2 and produce orders twice as often. So to reduce batch size by a factor of 2, setup costs have to be reduced by a factor of 4. I think that's part of that 5 is after. I'll spend a little bit more time setting up a little discussion on that. Okay? All right. The lead time when a pallet of gear retailer places an order to when the order is received is 2 weeks. If demand is stable, when should the retailer place an order? So 2 key decisions in inventory, or how much to order and when to order. Okay? And this, again, is right back into 343. We talked about that specifically there. So basically, if you know what your demand is and it's consistent, you can come back and just back up and say, if it's so much per day, then I'm going to place the order. It's going to come in perfectly, and we're going to go from there. Okay? So our reorder point is our lead time times our demand. Okay? But if lead time is greater than time between orders, there's going to be more than one order outstanding. I don't think that that's a huge deal in terms of what we're going to look at. Our inventory position is our inventory level on hand plus what we have on order. So when somebody talks about your position, you're not talking about just what you have in the facility, but we're talking about how much you have on order as well. And then back in the day, we talked about continuous review and periodic review. Continuous review says, like an ERP system, it tracks how much inventory is in there, and when it hits a certain reorder point, that's what triggers it to order. So that's a continuous review. Periodic review says, I'm going to monitor it over time. So think of periodic as time, and so I'm going to look at it periodically and take action when I look at it. And oftentimes, we use the periodic review when we're ordering on a time basis. So if I have a truck in Minneapolis once a week, okay, and they pick up on Friday in Minneapolis to bring it to wherever on Monday, well then I'm going to look at it on Thursday to place my orders to be picked up on Friday, right? And so periodically I'm going to look and see what I need to do. Okay? Okay, and then the last couple of things that we're going to talk about is just increasing batch size, increasing average inventory. So oftentimes the focus in manufacturing is how do we reduce our batch sizes. That way, again, we take inventory out of the system and increase the flow time. Okay? Average inventory is key over 2. The optimal batch size trade-off setup costs and holding costs. So to reduce batch size, one has to reduce setup time. And then again, we talk about continuous versus periodic. So again, Chapter 6 is just really kind of a review, bringing 343 back to the front of, kind of what we're looking at here, transitioning it basically into saying, now we take a look at it with throughput, how do we add in that flow time component, and maybe asking you to think a little bit more instead of somebody just giving you all the pieces of the information, more like it would be in the real world when you have some information and you can get to it, but you have to figure out those relationships, okay? So that being said, that's all we're going to cover tonight. I'm going to go ahead and put the I'll go ahead and publish the Chapter 8 problems, and probably tomorrow I'll put out the Chapter 6 problems that I want you to work on. The Chapter 8 problems, rather than doing it in a discussion board, I want you to go ahead and do them in an Excel file and upload the Excel file. Okay? And I give you a template in the assignment that you can.
And we use the
copy.
The college.
Yes. That performance spreadsheet. Yeah, I think that that's on the Chapter 8 page, but I'll double check and make sure that it's out there as well.
So do we have the goal questions too?
Yeah, we do. So should be moving right through with that. So, have you ever used your Oxford ODC tournament this weekend?
Next weekend.
Next weekend. All right. You've got a couple.
This weekend is the last weekend of regular season.
Okay. Where are you guys playing at?
UG Barn.
Okay. So was it your last home game here? Is that why you had senior night?
Mm-hmm.
Gotcha. Okay, I won't make you cry.
It's okay. I'm over it.
You're over it?
Yesterday was rough.
Yeah, I'll bet. Well, I'm glad you checked it out. I know something people do for like 3 years, and then that last year they kind of.
I almost quit my sophomore year.
Did you?
Almost did.
Yeah.
That was just because of my ACL injury.
Oh, okay.
It's one of the roughest things to go through.
It's a thankful 2 weeks after surgery.
The first 3 days
Oh, it's
are
terrible.
the worst. Something as simple as going to the bathroom by yourself, you can't do it.
Yeah,
You cannot do it.
Oh, really?
You're in so much pain because you're like, it was in the middle of the night, and I woke up, and I'm like, Mom? I'm like downstairs, so they basically moved my bedroom downstairs, and my mom's upstairs. I'm like, Mom? Well, I just uploaded what we did the observations time, so we got the times figured out. Okay. I think that was the last thing you said.
Yeah, on that day. Yeah.
So I fixed everything you said that day.
Okay.
So
And that's uploaded and ready for me to look at.
yeah.
Okay.
It's still on your talking point. Yeah.
Okay. Okay. So bring it back to that. Okay. That sounds good. And then Harley, you said you wanted to look at your project. Okay. Corey, do you want to stay on while I talk with Harley then?
Harley, I couldn't open the last file that you put on there.
Bye guys. Have a good day.
Thanks, Lisa.
That was a short and sweet one, wasn't it?
Yeah, they're all sort of sleepy, right?
Well, the other thing is that just don't expect that I'm just planning on you spending time outside of class on a project. So that's the balance, all right? Yeah. Okay. So that being said, how about if I try to open?
The words on
You said you put it on your group page.
Yeah.
What can I find? How do I get to that?
There's